Okay, welcome everyone. I'm David Rammel, editor of Visual Studio Magazine, here to moderate our first session as well as welcome you to our What's Hot and What's New for Blazor in 2023 Summit, brought to you by Developer Express, Grape City, Progress, and Visual Studio Live Microsoft HQ. Before we start today's event, we do have some announcements. First, we want to let you know this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Also, both of today's two sessions will be followed by a 5 to 10 minute Q&A. So please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you by our experts. And during today's second session, we will be giving away an Xbox Series X console, but you must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from our sponsors, Developer Express, Grape City, Progress, and Visual Studio Live Microsoft HQ available on the console right now, so please download and check those out. It's because of those folks underwriting this content that we can bring you this summit, so we thank them for sponsoring and supporting the community and ask you to check out those resources so we can bring you more events in the future. Now on to the first session of today's summit. What's new and what's hot in Blazor for 2023? This session features Rocky Lotka, VP of Strategy at Xspirit USA. Rocky, the creator of the open source CSLA.NET development framework, is also the author of numerous books and regularly speaks at major conferences around the world. He is a member of the Microsoft Regional Director and MVP programs. Rocky, it's great to have you here. Please take it away.
Well, thank you very much. Hello, everyone. It's a pleasure to be here and talking about one of my favorite technologies. I think that Blazor is, super exciting, and its underlying technologies, in particular WebAssembly, are really, really exciting. And so, as I talk through this, I'll kind of highlight some of each of those things. I'm going to start with a little background here, just to make sure we're all on the same page. Blazor is really quite new, and I've noticed not everybody really understands what Blazor is. And so, just to kind of level set, Blazor is an open source UI framework for building modern web apps. And Microsoft is the creator of Blazor, but it is an open source project available on GitHub. They accept pull requests and all the things that you would expect from any modern open source framework or tool. What sets Blazor apart, I think, I've been in the Microsoft space for a very long time, and so I've been involved in using and providing feedback to Microsoft on the way their UI frameworks work all the way back into the 1990s with some of the Visual Basic models and so forth. And I think what really sets Blazor apart is that the way I think about it, Microsoft had Visual Basic, then they had Windows Forms, they had WPF, Web Forms, ASP.MVC, and UWP. They've gone through quite a long list of different UI frameworks, each one of which has its own composition model for UI components or user controls or whatever they were called at the time, and each one of which had its own data binding model, and some of the more recent ones actually have had event binding so that you can bind methods in your code to like a click event or something like that that's in the UI. Blazor, what I think kind of sets it apart is that it seems to me like Blazor takes the lessons learned from all of those UI frameworks over all those years and really has constructed a powerful data and event binding model that makes it very easy to implement different kinds of UI design patterns, like MVVM or others. Very flexible, very powerful, without a lot of the ceremony and overhead that you might have encountered, let's say, when using XAML or some of the other previous technologies. It also has this really amazing way of composing UI components. In fact, the whole framework is based on what's called the Razor component model. And so every Blazor page is a component. And then components are just like a page, except they don't have a directive at the top that makes them into a page. And so what this means is that pretty much any time that you create a UI element or a page or a component or what you might have in the past called a user control, all of those things become reusable across your application in a very easy way that allows you to build up a user experience and make it easily maintainable and manageable, even as it scales into very large application models. From a slight history perspective, Blazor was originally built to support something called WebAssembly. And WebAssembly is a W3C standard that originally came out of Mozilla a few years ago. And it was an attempt, or well, not just an attempt, it was a successful attempt at saying, JavaScript is great as far as it goes, but JavaScript doesn't allow us to create applications that run in the browser using other languages like C, C++, C#, a variety of different languages that people have used and continue to use and continue to innovate on over time, especially if you look at Rust or Go, two of the more popular, trending languages right now. And so the train of thought is, boy, why can't we, instead of using JavaScript, or maybe in addition to using JavaScript, can't we just use Go and write code that runs in the browser? And so the way this unfolded is that the Mozilla folks created a prototype of this assembly language, got it running in Firefox originally, of course, and proved the concept, took it to the standards bodies and said, hey, this should be something that really gets built in to modern browsers. And so, fast forward to today, and all modern browsers, all the evergreen browsers, so Safari and Chrome, Chromium, Edge, Firefox, all of them support WebAssembly at the same level that they support JavaScript. And so it makes it possible now to create a web application using HTML, CSS, and Rust, or HTML, CSS, and C#. And so this is all based on a set of web standards, and it's not, I guess what I'm getting at here is that although Blazor is a Microsoft UI framework, Blazor sits on top of a bunch of web standards that are accepted and adopted by all of the modern browser makers. There's a vibrant WebAssembly community and a lot of activity, especially in the Rust community, but also in the Go community. And this is, Microsoft is in the middle of the mix, but this is definitely not just a Microsoft initiative. The thing is that if we go back in time here just a few years, when Microsoft was originally building out this Blazor UI framework to run on WebAssembly, there was still some uncertainty in terms of would Apple really embrace WebAssembly, or would they buck the web standards bodies? Fortunately, they're largely compliant. But because there was some of this concern, Microsoft chose to take the Blazor concept and actually make it run on an ASP.NET Core server. And so we end up with this really powerful model with Blazor today where I can build a rich, highly interactive, single-page application type model using WebAssembly and run it in the browser. Or I can take that exact same application code and I can run it on a web server, and then the browser in this context becomes essentially a very smart terminal. The user experience is the same. In both cases, the user gets this really rich interactive experience. The question is, did my code deploy and run on the client device, taking advantage of the CPU and memory of that device, or is all of my code running server side and we're treating the device like a terminal? And I think this is really, really powerful because it allows me to make architectural decisions that say, you know, I want global scaling. I want to take advantage of all of that client-side horsepower because then I don't have to have as much server cost and server expense in order to handle tens of thousands or whatever of concurrent users. And so that's a choice I might make. And in that context, Blazor running in WebAssembly on the client in the browser really provides the same kinds of application characteristics as you might find with Angular or React or Windows Forms or WPF. Or I might say, you know, I'm building an app. This app is departmental. It's for my organization, you know, but it's only going to be used by, you know, 150 concurrent users at a time. I never expect, you know, the application to, you know, be used by the outside world. It's just for my business. And I might choose in that context to run all of the code on the web server and just use the browsers as smart terminals. And, you know, so I've got this flexibility in how I host it. Now, more recently, Microsoft has added the concept of what's called a hybrid app. So this is something that runs Blazor inside of a newer technology yet called MAUI. And so MAUI is this UI framework that Microsoft created. It's really an evolution of Xamarin Forms, if you've followed that at all. So what MAUI does is it allows us to build an application normally using XAML, but the application then can be built and deployed to iPhones and iPads and Android tablets and Android phones, Windows devices, Mac devices, and even to Tizen, which is Samsung's operating system for things like televisions. And so, you know, MAUI is pretty neat in that it allows you to create native apps that run on all of those different platforms. The drawback, maybe, you know, depending on how you look at it, the drawback to MAUI is that it uses XAML instead of HTML and CSS. And so Blazor can be hosted inside of MAUI, and so it becomes realistic, and in fact it's a really fun way to build apps, I think, to build a Blazor app that then gets compiled, thanks to MAUI, gets compiled into a native app that you can put on your iPhone or your Android phone or whatever. So I've got a couple slides here just trying to address some of the most common questions that I have been addressing over the last few months in regards to where we sit today if I want to build an application using Microsoft technologies. And so this diagram is an attempt at a decision tree. So if you start at the top, there with the little black dot, your first question probably is, do you need to be cross-platform, or are you okay being Windows only? And these days, it seems hard for me to imagine that somebody would start building a brand new app and not choose to be cross-platform. Although I know that some folks do that, and I'm sure there are good business reasons for being Windows only. And of course, a lot of us already have, in fact, probably most of us have WPF or Windows Forms apps that we at least are still maintaining that are obviously Windows only. And so if you go on the Windows only side, WPF and Windows Forms remain valid options. They certainly, Microsoft considers them done, finished, right? They're kind of in maintenance mode. But this, using MAUI, we can create a Windows Blazor hybrid app. So we can build Windows apps using Blazor that are a native Windows app. And so that's certainly a possibility. If we do want to be cross-platform, then I think the next question that most folks wrestle with is, do I want a web deployment model where the user just navigates to a URL and they get the app, or do they want to install the app from a store, whether that be from the Apple Store, the Google Store, the Microsoft Store. And so if we say that we do want the store deploy, and there are various reasons why that's beneficial, right? These stores provide a curated experience. They make applications discoverable. They provide some branding. If you're trying to do an external public-facing app, you're perceived to be more valid if you're in the store. And so we can use MAUI in order to create these applications, or we can use the Blazor MAUI hybrid to create these applications, right? And it really depends on, do you want to build your application using XAML, or do you want to build your application using HTML, CSS? If we don't want the store deploy, if we want web deployment, which of course there's a lot of pluses to that too, right? Because you don't have to go through the store approval process. You can update your application at any point. You're in control in a much more direct way than you are when going through the store. Then your question really becomes, do I need to scale higher than a couple hundred concurrent users? And for a lot of applications, if you stop and think about, especially business applications, rarely do you have more than a couple hundred concurrent users. And so there's a lot of applications that fit in the model that can be built and deployed using Blazor Server, which is, and I call this out just because from a technology perspective and deployment perspective, it's probably the simplest of the models. But if you do need high scaling, right, if you've got, many hundreds, thousands, tens of thousands, or hundreds of thousands of concurrent users, then Blazor Server is not the right answer, and you want to go with a Blazor WebAssembly model. And here we've got a choice where I can either deploy a Blazor WebAssembly application just through a URL, or I can package it up into something called a progressive web app, or PWA. And this is increasingly common, this PWA thing. So if you're using your browser on your phone or your PC or whatever it is, you might have started noticing options to install your website as an app. And this is true for things like Twitter and Facebook. There's just tons and tons of apps or, websites out there that you can, quote unquote, install as an app. And then what happens, like on my Android phone, is that I end up with an icon on, that I can just click on like any other app. And although it's still technically a website or a web, a spa, it looks and feels a lot more like a native application to me as a user. The other thing that I get from a PWA is the ability to build an app that runs offline. so that because the app actually does get installed on my phone or my PC, if I go offline, some subset of the app's functionality will probably continue to work because it's designed to work in an offline setting. So this is like a drill down just to say that if we do want to use HTML, CSS, and I'm going to pause here for a minute because I think to me, this is something interesting in that when Microsoft came out with WPF and XAML originally, like a lot of people, I put a lot of energy into learning and becoming very proficient at XAML. And XAML is incredibly powerful. However, here we are, decades later, I guess, many years later, and I think it's fair to say that at the world at large, really, XAML didn't make much of a dent. It's still a fantastic technology, but the majority of the world has decided that HTML and CSS are the way to go. And so the way I look at this is if I'm trying to build an application using XAML, and it's like, man, I wish I could do this really cool animation, and I Google how to do that cool animation, I may or may not find any results because there's just not a lot of XAML out there. But if I want to do the same cool animation with CSS and HTML, and I search the web for how do I do that particular thing, I'm going to be overloaded with all sorts of cool ways to do the HTML and CSS animation. And so I can learn from those examples. I hate to say it, but like a lot of folks, I might even copy paste a little bit of that code, and I get to move on with my day rather than with XAML. I probably spend a lot of time trying to figure out how to do something that is just publicly documented with HTML and CSS. So again, when we start saying HTML, CSS, really the question comes down to how do I want to deploy it? Do I want to deploy it to the server with Blazor server? Do I want to give the user, take advantage of the user's client CPU and memory with Blazor WebAssembly? Do I want it to be installed potentially as an app with a PWA? Or do I really want to go through an app store, in which case I can use the Blazor hybrid approach? So this diagram is something also that I put together, and I'm not going to walk through everything on here because I've talked about a lot of it, but it's just a different way of visualizing your decision points on how you might decide whether to use one of these three different deployment models with Blazor. And really what I'm trying to get at more than anything else is that Blazor is incredibly flexible in terms of how you can use it. And so if you want web deployment, you've got that model, but there are some interesting trade-offs. Like, do I need to use local device features that are not available in the browser? In which case the only option is to use a Blazor hybrid with Maui, because Maui creates a truly native app that has full access to all of the client-side APIs and capabilities. Whereas web pages or websites, and this is Angular, React, or Blazor, running in the browser, are always running in the browser sandbox. And so they can do an awful lot of things, and in fact, over the last several years, we continue to see this increase in capabilities where browser-based code can interact with your geolocation, they can interact with your camera, microphone, and so forth. So a lot of applications probably can be built that run just great inside of a browser scenario. But in some cases, you definitely are going to have to access local hardware devices, drivers, or APIs that you can only get through a native app. And so that hybrid model becomes pretty powerful. So when I think about application development, my background is primarily focused on building business applications. That's what I've done through most of my career. And most of the applications that I've built in my career, at least since the mid-1990s, have been some sort of end-tier or service-oriented, the SOA or microservices or whatever. But what I'm trying to capture with this diagram is the idea that if I'm creating a Blazor server app, the browser is acting like a smart terminal, and Blazor uses a technology called SignalR to send messages between the browser and the server in a bidirectional way. My code, my Blazor app, is then running on the server. It might talk to an app server, an application server, or it might just talk directly to the database. And that's pretty common for server-side architectures. If I'm running Blazor in WebAssembly or in a hybrid model, my code, my Blazor app, is actually running on the client device. And so there are some advantages to that, especially in terms of scalability, but also in terms of taking advantage of client-side capabilities. In both of those cases, though, if I'm building some sort of an enterprise app, I'm certainly talking to an app server, and that app server might expose traditional end-tier services, or it might be exposing microservices. That is a whole different architectural conversation, but you hopefully can see how this fits together. I can also use Blazor in a one-tier model. So if, in other words, just client-side only with no server stuff at all. And so if I'm using Blazor WebAssembly, so the user just navigates to a URL and is taking advantage of Blazor running in the client device, now my app running in Blazor can interact with anything the browser can do on the client device. And so again, like I said, that might include geolocation or access to the camera, but it also includes limited access to the client storage, so the hard drive on your PC or whatever. And so it becomes realistic to write apps that are running on the client device that are using data that's stored on the client, and that you'd never talk to the server after the app has been deployed. Now, this is particularly useful if you deploy this using Progressive Web App or PWA technology, because it gives you more capabilities around accessing client-side data. But it's important to remember that in all cases, when you're running in the browser like that, you're running in the browser sandbox. And so your ability to access the local device is limited. And so generally this is considered a good thing, right? We don't want some malicious website filling up my hard drive with garbage. But it can be a drawback. So not that long ago, working with a client, we were building an application that needed to work offline, needed to have client-side data and so forth. And we started building it using a PWA, and then rapidly realized that the limit on the amount of data that a website can store locally was too restrictive for the data that we needed for this app to work, because we had to have machine diagrams and all sorts of things like that, some of which were fairly large. So we switched to a hybrid model where the application was a native app that could run on the phone, but was still running web technologies inside the native app. So the Blazor hybrid model allows you, because it's a native app that's running really on the device, it has access to the whole hard drive or whole storage of the phone. And so we were easily able to store all the data we needed and put it on the client. So again, I've talked about this, our three different models for deployment. If we look at this, there are consequences to these that I just want finalize here. So on the Blazor server, the upside is that it starts up very fast. For Blazor WebAssembly, the upside is that it scales very, very well. For a PWA, the upside is that it scales well and provides online and offline capabilities. And the App Store model, so the Maui hybrid model, provides local device access, online, offline, fast startup, and scalability. So you might go, wow, clearly this Maui hybrid is the way to go. But there are some negative consequences. So the Blazor server model is a stateful model. And so even though its startup is very fast and its deployment is very easy, the reality is that it has limited scaling because of the fact that the server is maintaining some state. Blazor WebAssembly has a drawback in that the initial download of the application might take substantial time. And that's because we are running this in .NET, and so my .NET code or your .NET code all gets compiled into WebAssembly, and that's usually not very big, so it downloads pretty fast. But we're relying on .NET itself, and so the .NET runtime also has to download in order to use the application. And so the first time the user hits a Blazor WebAssembly app, it might take several seconds to download everything that is necessary. And on subsequent loads of that URL, it's all cached in the browser cache locally. But this is a very real concern that you have to, I think, weigh carefully. The PWA has the same problem with the initial download. The App Store, even though it seems to have all those green checkboxes, actually the store approval process can be a real problem for especially a lot of business application scenarios, right? Because I've got this real high priority bug that has to get fixed right now, but I can't fix it until Apple approves or Google approves my app that I submitted to the store. And so we give up a lot of control there. Now, if we think about Blazor, and like I said a couple times already, Blazor creates single-page applications that are highly interactive, highly responsive. They're modern, fantastic apps. And so the first thing that a lot of folks, I think, rightly do is they say, well, how does Blazor compare to Angular or to React or to Vue, whatever JavaScript framework you're used to? And so Blazor also, just like Angular and React, everything is HTML, CSS for the actual UI design. Obviously, the next bullet point is where there's a huge difference in that if I'm creating JavaScript framework code, I'm using either TypeScript or JavaScript for my code. And if I'm using Blazor, my code is going to be written in C# with .NET. And so this is one of these cases where people say, well, I've invested the last 10 years making my development team really competent with JavaScript and TypeScript. Should I look at Blazor? And you probably won't want to switch to Blazor. I'm not going to say you don't for sure, but it's a hard thing if you've got your whole dev team tooled and skilled and certified whatever else in building code with TypeScript to then say, well, we're going to go back and learn C#. On the other hand, if you're a shop and there's a lot of organizations out there that are still building most of their code using C#, whether that be ASP MVC on the server or web forms or Windows forms, then Blazor becomes really attractive because now I can build modern websites and modern web apps just using C#, and I don't really have to worry too much about JavaScript. Architecturally, other than that, they're pretty much the same, right? They can both call services on the server. They can both execute code on the client. I think Blazor has a bit of a nod here in that, unlike the pure web technologies, Angular and React, Blazor does have the option to run your code on the client or on the server without changing your code. Another way that folks look at this whole thing, and they say, you know, I've got this massive investment in Windows Forms or WPF. I would like a road forward that gets me cross-platform, that gets me into the, you know, more modern development world. But I don't want to completely retrain all of my developers on Angular, React, TypeScript, and so forth. And so I think Blazor here is potentially compelling. The UI for Blazor, of course, is HTML, CSS, whereas like WPF, it's XAML. And so there's definitely some reskilling that has to happen there to get everybody, you know, to learn HTML, CSS instead of XAML. But your code remains in C#. Your services on the server can remain the same. I can execute my app on the client just like I do with WPF. But I could execute the code on the server if I want to. In any case, the Blazor code runs across all modern devices and browsers. So I think there is a compelling story here, but it's definitely, you know, not a free, it's not like it's a simple migration, right? You're going to have to redesign your user experience out of XAML and into HTML and CSS. So the thing with Blazor is, like I said, it's relatively new, and so it's changing very rapidly. So, you know, we've had Blazor in some form or another now for, I think, about 3 years. .NET 7 just came out recently. .NET 7 with Blazor has a whole ton of performance improvements. It has dynamic authentication requests to enable some really cool scenarios that were hard to do before. It has new ways for my Blazor app to interact with existing JavaScript libraries. And that's powerful because there are charting, graphing. I mean, there's just such an amazing array of existing JavaScript libraries out there for doing cool stuff in the browser. And the fact that Blazor can now more easily interact with those and leverage them is really beneficial. The flip side is also true in that Blazor now supports something called custom elements. And so it's possible for you to create a Blazor component that is used as part of a UI that might mostly be built using something like Angular. There are new project templates. You know, when Blazor first came out, the only project templates that Microsoft supplied were ones that really are geared toward helping us learn how to use Blazor, which was great at the beginning. But nowadays, if you've been doing Blazor for a while, I really just want to open up an empty project template and put in my own stuff. I don't need all of that kind of tutorial code that has been there. So that's a big improvement in a lot of ways. The way that you can build your code to navigate through Blazor pages has been improved a lot. They continue to improve data binding with a bunch of new capabilities that you can know that you're about to be data bound, that you've been data bound, that individual values are being get or set. There's this thing, too, called ahead of time compilation, which really is not a Blazor feature. This is something that has been worked on for .NET Core and just .NET in general quite a lot. And it's the idea that for its entire existence, .NET has been just-in-time compiled. So, you know, as a developer, I do some level of compilation. I end up creating this DLL or WebAssembly file that then gets just-in-time compiled on the client device or on the server right before it gets run. And so there are some advantages to that just-in-time compilation, but there are some disadvantages too, in that it takes a little bit of time and energy. And so suppose that as a developer, my compilation time got extended. In other words, I do a lot more of that compilation up front as a developer, and then when the code gets deployed to the client device, it's already completely compiled. And so then it starts up much, much faster. There's some other advantages, but that's the big deal. And with Blazor, this is kind of a really important thing because of the fact that WebAssembly applications do have this startup lag. That first load might take a fair amount of time, and so ahead of time compilation helps with that. And they continue to enhance. This is a complex technical area that is something that has a huge set of improvements in .NET 7, and I'm sure we'll see more going forward. Also today, there's the ability to do multi-threading in the browser that's experimental. This is a little tricky because the browser and actually WebAssembly itself don't natively support multi-threading. And Microsoft is doing some clever things in conjunction with the WebAssembly working groups to try and get WebAssembly to support multi-threading. So it's kind of exciting future stuff there. And so speaking of future stuff, .NET 8 is in preview right now. We anticipate .NET 8 coming out later this year. And so nothing in .NET 8, I think, is set in stone at this point. We've got previews. We don't even have a beta yet. So, but what we are seeing today is a new quick grid component. One of the most common things that we do in especially business apps is display tables of data. And so thus far with Blazor, we've handcrafted our tables using the HTML table element or div tags or whatever it is. The quick grid component is a more powerful abstract way of creating basic tabular data. Now, this is a great point for me to just stop and interject that the world at large, there's a ton of open source projects that support UI components for Blazor. There's a whole lot of commercial products out there from different vendors that provide really amazing capabilities and components for Blazor. So the ecosystem for Blazor is large and continues to grow, and it's incredibly vibrant, which is very exciting. So if you've already looked and found some grid component from a vendor or open source project, you might be like, I don't care about that quick grid thing. But if you're just getting started, having at least this basic entry point to create tabular data is, I think, really powerful. And then you can graduate to one of these more powerful options as you need to. .NET 8 continues to have a whole bunch of WebAssembly performance improvements. And then maybe the biggest thing is this idea of something called Blazor United, which is a capability where, and this may or may not come to pass, right? But this is the idea that Blazor, a user might come to your Blazor site and initially get a Blazor server experience. So it's a very fast load, very quick, and then behind the scenes, they might be concurrently downloading your WebAssembly code and switching over to client-side code, all transparently. So this is some pretty ambitious and very, very cool stuff. Along with this is the idea that maybe we can start using Blazor components when we're creating ASP.MVC type code as well. And so, again, this is prototype stuff. There are some YouTube videos out there from Steve Sanderson that you can look up that show at least what their initial thinking is. If it comes to pass, it's very exciting, and I certainly hope it does. So with that, I'm going to close. I'll take some questions. I think we have a little bit of time for that, but I do appreciate everyone's time today. Thank you.
Okay, great stuff. And we do have some questions in the Q&A portion. And I would like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session so please send them on in now. And let's get to those questions. We'll take them first come, first serve. First question comes from Chris in the audience. He says, what about traditional LOB applications, line of business applications? I've researched .NET MAUI and also WinUI3, but they seem to be too web-like for a complex, busy layout typically used by a desk-based user. What do you think about that, Rocky?
Well, I think that's a real question that is something that probably doesn't have an easy answer. I have seen and have been involved in building some really complicated apps that have web-based user experiences with a lot of different, user controls, input forms, and that's what I'm hearing from this question is, I've got a true enterprise app, right? And I've got these complex screens that are data entry with a lot of input controls and probably a lot of different overlays. The user maybe stays on one screen, and I've been there. I've been there. And the thing with the modern web is, with HTML5 and modern CSS, the capabilities of Blazor, or to be honest, Angular or React, is that you can build that kind of app, and I think it's very realistic to build that kind of app using web-based technologies today. The web has, if your picture of what the web can do is even 5 years old, it's pretty out of date because this technology has changed and evolved very, very rapidly. Especially, I would go back to 2008 to 2010 is when everything really started to shift heavily into the web-based model. And so over that, last 10 to 13 years, boy, oh boy, the capabilities of what we could or couldn't do back then compared to what you can and can't do today is night and day.
Okay, great. Well, the questions are rolling in now. We have a big, active, engaged audience, so let's get through as many as we can. The next question comes from Sashi. Sashi says, with the Blazor server app hosted on an internal server with limited number of users, will we still be able to use HTML and CSS?
Absolutely, yes. So Blazor, in all three of the hosting models, Blazor uses HTML, CSS to create the user experience. Or actually, I should flip that around and say, you use HTML and CSS to create the user experience, and the code that's running behind the HTML, CSS is C#. And that is true for Blazor Server as well as Blazor WebAssembly or MAUI Hybrid.
Okay, great. There's a question from John. Why do you think Blazor Server is not scalable?
So Blazor Server requires a stateful session on the server. So the browser is treated as a smart terminal. It's an endpoint for the user, but all of your code is actually running on the server. And that is persistent in memory on the server. So every user that's connected to your server is consuming a certain amount of memory and resources on the server. And various folks have done, different kinds of testing and scaling and there's some real world data out there now, of course, that shows that again, it depends on how big your web server is, but it's realistic to think that you're going to, on a web server, support maybe 150 or 200 concurrent users. Now, it's true that, of course, you can just add more web servers and scale that way. And so the thing is, though, that if you're if a web server goes down, all of the users connected to that server also lose their session. So they also go down, right? So in my case, I'm old enough that this is how I started my career. It was on mini computers and working adjacent to mainframe type models. And so this is really similar architecturally to those models, where if the computer goes down, then your users lose their work. So yeah, I think it's fair to say that server-side Blazor can scale by adding more and more web servers, but you suffer this risk of lack of fault tolerance that in what you normally think of as modern web is probably not an issue because the web servers are stateless. And in any case, it becomes more cost effective to scale if you're using the CPU and memory of client-side devices. And this has always been true, right? This is a lot of why we went to smart client applications back in the 90s and why there's a lot of Angular and React single-page apps now is to shift some of the workload off the server and onto the client. Because everybody's modern phone is, a 4, 6, or 8 core computer, right? I mean, it's take advantage of that horsepower so you don't have to spend it on huge servers.
Okay. We're running out of time, so let's try and get 2 more questions in. Here's one from Noel. Are there improvements in WASM debugging?
So that's something I really didn't touch on in the talk, and I probably should have, and that is that the debugging experience between the 3 different hosting models varies. So debugging in Blazor server is very powerful and very much like any other .NET debugging experience. And debugging in Blazor WebAssembly is definitely different because your code, your .NET code, got compiled to WebAssembly and is now running in WebAssembly in the browser. And in the early days of Blazor, the debugging experience was horrible, almost non-existent. Today, the debugging experience is pretty good and continues to improve. And so I guess the answer to the question is yes, it has improved. I don't think it's still as good as Blazor server. I still, when I'm building even Blazor WebAssembly apps, will do a lot of my basic development work in the Blazor server model on my development workstation because the debugging is better. And then I'll do any sort of final debugging by compiling it and running it into the WebAssembly model.
Okay, last question. Actually, a couple of people question the same thing. One says, why use Blazor instead of React? And another said, from a user experience perspective, is there an advantage to Blazor over Angular React?
I touched on that a little in the slide earlier. I think at this point in time, there are probably 2 things to look at. One is that React and Angular have been around for many, many years and are much more robust just because of the fact that they've been around for a long time. And so they've had more time to build components and an ecosystem. Blazor is roughly 3 years old at this point, and it's still a newer technology that's evolving quite rapidly. And so when I look at that, there definitely is more maturity in the Angular and React ecosystems than there is in the Blazor ecosystem. But I think that's a short-term issue because the Blazor ecosystem is vibrant and really active. There's a lot of excitement. The other way to look at it is to say that if your existing team is really good at Angular or really good at React and you've invested in building up those skills and capabilities, I would have a hard time making an argument that you should switch to Blazor. On the other hand, if your development team is primarily .NET and, maybe you have done some Angular, but you're kind of hands off or keeping it at arm's length, and a lot of your web development has been ASP MVC or has been web forms, and you're primarily a C# or .NET development shop, and your team is primarily .NET in skills, then Blazor becomes, I think, really compelling because it offers much the same capabilities and the same kind of user experience and the same end result that you get with Angular, except that you're writing your code all in C# and using .NET.
It looks like that's all the questions we have time for. So thanks again, Rocky, for an excellent presentation and answering all those questions.
Absolutely. It's been my pleasure, and I hope everyone enjoyed their time here today.